Hi there, I'm going to be talking through my Advanced Graphics and Real-Time Rendering Level 6 assignment, and I'm going to be going through some of the more interesting things that I feel I've implemented really well, and I think that stand out on this project. So one of those being what I'm showing right now, which is the program will continue running after it's already opened, whilst actually compiling more complex shaders, so shaders that contain large unrolls and take a very long time to build at runtime. uh, I've gotten around that by moving the loading of those onto a background thread that will process any shaders that are wanted to be loaded. So that's my self-shadowing parallax there. So if I get point light 2 and there it is, and I move it around a little bit, we can see those shadows look really nice. But say you didn't want your brick wall to be self-shadowed, you can turn off self-shadowing, and now because nothing else is using occlusion, it's then going to compile the occlusion. Then we've got the occlusion parallax, and then let's say you don't like occlusion parallax and you want to see steep parallax, well, you can turn that off and it will then compile the steep parallax one. And then you can turn that off and it will show you the parallax one, and then you can turn that off and it shows you the normal mapping one. So this like deferred loading of shaders and kicking them in while the program's already running is made possible because of my shader reloading system and the way I've architected how an object gets a shader. I have a shader cache, and this stores all of the shaders that are needed and then can like jump between which shaders, and then it's got shared functionality for getting all of these. So then in my rendering engine, when I actually go to use a pixel shader, it goes through recursively until it finds the perfect pixel shader for you based on your settings. So the actual implementation for being able to just go, okay, these want to use normal mapping, show them with normal mapping. If they want to use parallax, then if parallax is available, use that. If they want to use steep parallax and that's available, use that. And it makes this whole system of having all these different shaders really well implemented and really like simple to implement more things and use. Um, so yeah, the normal mapping being shown on these two cubes, and then also parallax and all the different parallaxes being shown on there. So the next thing after that is the different post-processing steps that are done. So all of this has actually been shown being rendered directly to a full screen quad, which then has my ImGUI UI placed over the top of it. So this full screen quad is done during my post-processing pass down here. Post-processing pass. So what this does is it will take the render result of having rendered the scene once, and then if deferred rendering is on, it does the deferred rendering things, and then it goes through for every post-processing pass that I've got, and it increments and then saves out, and it goes through for everything, which makes it super simple to just add and remove more post-processing effects and combine them in really interesting ways. And then some of my post-processors contain additional post-processors within them that they run, which allows for what I think is a really cool looking effect, and it's incredibly easy to add and remove more ones, which is why I've added some that aren't on the mark scheme because I was just having fun with it. So the first one that I've got is a debugging option, which just renders out the current depth buffer. This is really helpful for working out why there are things going wrong with other shaders and like trying to think about what could be happening and why this shader just isn't working properly. The next one is a pink one that just adds pink to everything. I've then got another simple screen space effect that just turns everything grey. It just averages your RGB values for every pixel. Very noir. Then we've got the Gaussian X, and we've got Gaussian Y. When these two are combined, you get your full Gaussian blur effect. This is used in other shaders lower down, as I'll get to. So then I've got the drunken shader, which is just a little fun one. It just takes a sine wave and then samples to the left and right, oversampling its own texture to give this like wobbly effect. I've then got this one, which is a debugging pass for how my HDR bloom is actually going to apply bloom. So this is the actual bloom result from the HDR bloom itself separated out into a separate pass just for debugging. So if I take point light 2 and I move it down to the surface, you can see that the surface gets a lot more visible in this texture. And if I bring it up, it fades away. This is because when this light is too close to the surfaces, it's causing all the surfaces to have an extremely high amount of light applied to it, which then means it exceeds the SDR range, goes into the HDR range, at which point it then gets applied to my bloom texture. That's not what I meant to do. So if I just pull that back up, it's a lot more easy to see if I turn these off. So you get a nice smooth edges for where the blur is going to be. So then if I apply HDR bloom on the top of this, we can see what the bloom texture itself that gets applied will look like. So if I just turn back to this, this is my base render, nothing fancy going on. Then I turn on bloom, you can really see these surfaces that are bright. Oh, that's 0.5 by 0. There we go. All these surfaces that are really bright start to get this really nice, just like bright blur around them to show like this surface is extremely well lit, and it adds in some of those artifacts that you'd normally get on a normal camera. And if I turn normal mapping back on, you can see that it's now applying into the normal map, but it's a bit harder to see if I bring up the intensity a bit. Yeah. And similarly, it still works with parallax and all my other lighting options. There you go, you can really see it on this like section here. So it doesn't work as well on this one because of the fact that not much of it is directly in the light. You can see like some of the bits where it's really bright are starting to bloom though. Yeah, what do I show next? Next is the depth of field blur. So from this depth buffer from earlier, we can then apply a depth of field blur, which allows for objects that are further away to get blurred. As I get close, they unblur. So this can actually be used in a couple of really cool ways, this same technique. I've actually used it for applying a depth of field color. Very like reminiscent of Sin City with the one very brightly colored thing and everything else just grayscaled. So this is combining my gray texture from earlier, the base texture, and then that's being run through a depth of field check. And then I've done the same with the drunken shader here. So this is the drunken applied to these cars, but if I fly away, then I fly back. And then the last shader that I've got for the screen space effects is motion blur. It's very nauseating, but it works. It blurs when there is motion. This is only a simple motion blur that works on the screen space. I didn't get a chance to go through and do a motion blur on other objects moving around the scene, but I think that would have a very cool effect, especially with like the car object and stuff like that. And then the last thing that I've got to show is my deferred rendering pipeline. So I started my deferred rendering pipeline, and it works, but I sadly didn't get time to implement deferred rendering support for normal mapping or parallax mapping. So these nice parallax and normal mapped shapes over here will just be shown as their base color. So the three passes to normal mapping are the color pass, the normal pass, and the position. So here's just the base color. As you can see, all that lovely lighting's gone, and all that lovely normal mapping and parallax mapping is gone. It's just a case of I didn't have a chance to properly go through and add in the shaders for them, but I know how I do them, which is very frustrating. Then I've got displaying the actual normals of a surface, so it's very visible on these cubes where, X, Z, Y. It makes it very evident it's working. I really like how it looks on the teapot as well. Those nice bits. So this is just what are the normals of every surface, how do they come out of being run through an extra pass. And then there's the position pass. This is done in world space, so it leads to a very weird looking result, but this is getting the positions of every object in world space and then applying to it. So I think this looks funky. So then when a deferred rendering is then applied, we're now going to be taking these three different passes and applying them all into a single surface, which then gives this result. So it looks very similar. It's got a lot more specular on it. That's just because of different lighting values being used mostly, but also the skybox disappears because now there's no the skybox is being factored into the lighting, whereas normally my skybox is using a separate shader. But if I move this light up and I increase that and decrease that, let's give it a bit more of visibility across the scene, you can really see how these lights are like blending and how they look when combined with each other. So if I make this red, we see that it goes red. If I make it blue, I increase the intensity, decrease that, and I bring this blue cube over this way. You can see that it's making this section of red here, it's blending it to purple and then eventually to blue as it combines these two different light sources that are both being run through, being this blue cube and this red cube. Yeah, I think that's... Oh, there's one more thing I need to show off. So then one way that I've actually been able to help myself when working on all of these shaders and all of this other stuff is I've actually implemented deferred shader loading. Sorry, I've implemented real-time shader reloading. So if I open this and I change it, let's just make a simple... Oh no, let's not use that one. Let's use standard pixel shader, so it's really evident when it happens. So if I... Simple syntax error, you know, happens all the time. Rebuild pixel shader. The shader file standard pixel shader.hlsl cannot be compiled, at which point it compiles the error shader, which once it finishes recompiling all the shaders in the scene, you'll see how that looks. There we go. Then everything using this default shader has now turned pink. So if I go back over, these have stayed exactly how they are. That's just some weird lighting settings I've got on there. And then this has gone pink because that shader didn't compile correctly. But if I fix that shader, and then just to show this isn't doing something weird, like 0.1, 0.200, and then shaders, rebuild pixel shader. Oh, it's still upset. Can I do that? Apparently not. It's because I'm adding a float 3 to a float 4. Maybe. Once this reloads, it's still going to have an error, so I think I'll reload it again. And then now this isn't broken anymore. If I reload it, once it finishes reloading, everything will go back to normal. And there we go, it's back. Yeah, I hope I've explained everything well. That's my graphics assignment. I hope you had/have a good Christmas. Right, bye.